algebra students. We're going to be taking another page of notes today, and this is actually your last topic in this unit. So we're going to be working on some word problems, and we're going to be working on why would we need to use these equations, and then at the end of this week you're going to be taking your unit test. So think about where we've been so far in this unit. If you look back through your notes, the first set of notes that we took in this unit was solving multi-step equations using the DCBA method, and you've been practicing that. So that's the first topic that's going to be on your unit test. The next thing that we have learned about is solving equations with either one, infinite, or no solutions, and so you practiced that. And then the last thing we did last week, there's a second page of notes there. Last thing we did last week was solving literal equations. So those solving multi-step equations and one, no, infinite solutions and literal equations are all going to be on your test for this unit. The last thing in this unit that we're going to learn is, again, like I said, word problems and real-world applications. And so this page is going to be called Writing and Solving Practical Problems with Equations. And so we want to look at, well, where would we ever really need to use this, or how can we use equations in the real world and not just in algebra class? All right, there's going to be a lot of writing because, of course, we do have to write out word problems. So let's just jump right into it. Example number 1. All right, so hopefully this has never happened to you, but once upon a time when I was in college, my best friend's car got towed, and so we had to call a tow truck. So when a tow truck is called, it's not cheap. The cost of the service is $110 plus, so first of all, when you call a tow truck, they charge you a fee. Like they say, we'll come get your car for $110, but then they add plus $15 per mile that the car must be towed. Because if they have to transport it very far, that's going to, of course, rack up more and more dollars. So $15 per mile that the car must be towed. That means if they tow it 1 mile, they're going to charge you an extra $15. If they have to tow it 2 miles, they're going to charge you an extra $30 on top of the $110. All right, so sad ending to the story. If the total cost of your bill is $147.50, then what we want to know is how many miles did your car have to be towed. So you might want to pause the video and make sure you get all that written down. And then we're going to talk about, okay, 2 things. Number 1, how can we write an equation from this situation? And number 2, then, how can we actually solve it to answer the question? So there's going to be how many miles? That is supposed to say miles. Why did I write mild? I don't know. That's supposed to be an S. All right, how many miles? That makes more sense. Did your car have to be towed? All right, so step 1. Always, always, always when you do this, you are going to define the variable. So you can make a note of this on your paper or just, maybe make a 1 and say, this is what I'm going to do. First, define the variable. What is it that we do not know? And usually that is answered in this very last question. It's the thing that's missing that you're looking for. Remember, variable just means the thing in math that we do not know. And so what is it that we do not know here? It's how many miles did your car have to be towed? All right, now you could use any letter. I'm just going to choose to use X because X is the most commonly used one. And so what is X standing for in this problem? We do not know how many miles. So I'm just going to make a little note off to the side here that my missing variable, define the variable first, X is going to stand for miles. That is what I do not know. It's how many miles did it have to be towed. All right, step 2. We are going to determine the constant. So what is it that does not change throughout this whole problem, depending on the miles? So like, what is it that no matter how many miles you're going to go, does not change? And so that is usually the number that is the flat fee or the flat rate or the number that you're going to be charged first, or how many there are. And it's not the $15 per mile because that's going to change based on miles. The thing that is constant, the thing that is not going to change no matter how many miles I go, is the 110. So we're going to write that down. That is what I would call my constant. It's the number that does not change. All right, step 3 is to define the rate. Find out what your rate is. Well, the rate is, what is it that is going to happen every single mile that you go? What is the amount of money that you're going to be charged based on what is varying here, the variable X? Well, that's the 15, right? It's $15 per mile. So $15 every mile that you travel, that is what we would call the rate at which you are being charged. So the rate here is going to be my 15. All right. And then last but not least, step 4, we are going to write an equation. Now, of course, every equation is going to be different, but in general, now this is not a hard and fast rule, so when it changes a little bit, don't go saying, oh, Miss Wallace, you told us that this is always how this is written. In general, when we write an equation, here's what it's going to look like when we're given these things. When we're given a variable, a constant, and a rate. Normally, we'd write it, and I'm going to write this in a different color. You can just write it regularly, but normally we're going to write the rate times the variable plus the constant, and that's normally going to equal a total. Now, we did not define a total anywhere, but usually in your problem, it's going to be very clear. It usually tells you this is the total. So you could even add that to your list here about what is my final or total answer going to be. All right, so let's write an equation, and let's see if this makes sense. So what is my rate? Well, my rate is $15, and I'm being charged $15 every mile. That's key right here, is the $15 per mile. That goes with my rate. And so I'm going to write down 15 times, I'm going to need to multiply 15 times every mile because, and I can just write that as 15x, because again, if I go 1 mile, I'm going to be charged $15. If it's 2 miles, I'm going to have to do 15 times 2, which is 30. They're going to charge me $30. If I get towed 3 miles, then of course that's going to be 3 times 15. And so you can see how the 15s are just going to add up. That's why we have to multiply this here. Okay. Then we're going to add the constant. So the constant here was the $110. And so we're going to write that down. And notice how that makes sense, right? We're building up a total cost here. So it's $15 for every mile plus the $110 that they charged me at first. And that's going to equal what the problem was telling me my total was. And of course, the problem just told me that the total was $147.50. And so we think about that. We make sure that makes sense. Does this equation match this? Yes, it's $15 per mile plus the $110 they charged me at first, and that should add up to equal the final bill. And now that we have this equation written, now we're actually ready to solve it. So the first step, of course, is writing this equation, and then step 5 is actually to solve. Because the question is asking us, how many miles did our car have to be towed? X is miles, so if I solve for X, I'm going to know how many miles I got towed. So we're going to solve it just like normal. We're going to subtract 110 from each side. You can use Desmos to do the math here. 147 minus 110 is 137.50 divided by 15. Oh, not 100. Why did I put that one there? It's 37.50. And then 37.50 divided by 15 is 2.5. So my final answer is 2.5 miles. That's how far this car was towed. And so we're going to go through the same process. When you're practicing in this particular topic, you're going to have to be able to define, of course, the variable, the constant, and the rate. That's going to be part of your practice. You're also going to practice writing these equations and then, of course, solving them. So there's really 5 sort of steps that we have to do here. I don't have much room at the bottom of my page. Maybe you do, but we're going to do the next word problem on the next page. So let's flip that over. This is actually page, let's see, this was 12. That was 13. I forgot to label it. And we're on page 14 now in your notes. All right, so example number 2. All right, let's say that you and 6 friends go out to eat. You have a coupon for $25 off the entire bill. If the total bill after you eat is $120.94, how much would each person pay? All right. And I'll give you a second to finish writing that down. And then we're going to make a note, of course, of our variable. We're going to make a note of the constant. We're going to make a note of the rate. I'm actually going to make a note of the total this time as well. And then we're going to write our equation. All right, so let's look at what we know. Our variable, what is it that we do not know? Again, it's normally in that last sentence of the word problem. How much money would each person pay? We're looking for how much would each person pay. So I'm just going to mark that as pay. How much money will we pay? Maybe say money paid. The constant, what is it that's not going to change no matter how much each person paid? What is it that will not change? Well, in this case, it's this coupon for $25 off. Now, we have to make a note that this is $25 off. And so the constant here is going to be negative because we're actually going to be taking money away because it's a coupon. So the constant is negative 25 in this case. The rate is the thing that's going to be multiplied by the variable. So what is it that we're going to be multiplying by? How much people paid? Well, one person's going to pay so much, 2 people are going to pay so much, 3 people are going to pay so much, 4 people are going to pay so much. So how many people are actually paying here? That's going to be our rate. How often are the people going to pay? Well, the question says you and 6 friends, so how many people are actually eating here? And this is a little tricky. You and 6 friends make 7 people, right? So our rate here is going to be 7 because 7 people are going to pay the same amount, assuming that we are splitting the bill evenly, right? We have to make that assumption. The total, of course, is the 120. That's usually the easiest thing to pick out is 120.94. That's our total bill. And now we're ready to write our equation. So again, remember, in general, it's rate times variable plus the constant is equal to the total. And that's the form that we generally will follow. Again, that's not a hard and fast rule, but in general, most of these problems are going to follow this. So 7 times the rate, that's 7 people each paying the same amount. 1 person pays this, 2 people, 3 people, all the way up to 7. Now, we're adding the constant, but notice that our constant is negative. So instead of adding the constant this time, because it's negative, we're actually just going to subtract it. So we're taking away that $25 coupon. And then our total was $120.94. And so now we're ready to solve, and we're ready to figure out how much actually everybody ate. So we're going to add 25. That will cancel 7x on this side. $120.94 plus 25 is $145.94. Divide that by 7. You can, again, type that into Desmos, and you get $20.85. And I think it comes out, let me type that into the calculator real quick. I'm pretty sure that comes out even. If it doesn't come out even, sometimes you may have to round 145.94 divided by 7. Oh, it didn't come out even, actually. In your calculator, you probably got something like this, or maybe in Desmos. And so again, since it's money, because our variable was how much money are you going to pay, of course, this is not money, right? So we have to do $20.84, but this 8 is going to round that up. Money only has 2 decimal places. So we look at the 84 and we say, oh, that rounds it up to 85 cents. So that's why it's $20.85. All right. Let's do one more. I'm going to write it out. I'm going to let you practice it on your own, and then all of the, of course, equations are going to follow the same sort of pattern. I'm going to go on to the next page just so I'll have enough room, especially with the word problem, so I'm putting this on page 15. So example number 3, your cell phone company, whoever they might be, charges $75.50 a month. That's your monthly bill, plus $15.25 each time you go over your data limit. Now, some of you may have unlimited data and you don't have to worry about that. Unfortunately, I have a limited data plan, so I have to worry about going over my data every month. If your total bill is $121.25 this month, how many times did you go over your data limit? Thank goodness for unlimited data, right? All right. So again, we're going to go through, pick out the variable. I'm just going to call it V. Pick out the constant. We're going to pick out the rate. We're going to pick out the total. And we're going to write our equation in the end. All right. Variable. What is it that we do not know? Well, we do not know how many times we actually went over our data limit. So X is going to stand for number of times over data limit. That's what my variable is standing for. My constant is the number that is not going to change no matter how many times I go over my data limit. The constant does not change depending on the variable. So what is it that will not change no matter how many times I go over my data? Well, it's that my cell phone company is going to charge me $75.50 every month, right? That value will not change no matter how many times I go over my data limit. So that's my constant. The rate, of course, is the thing that you're going to multiply by the variable. So the rate is, well, if I go over my data limit this many times, how much are they going to charge me? So the rate is $15.25. If I go over once, it's just 1 times this. If I go over twice, it's going to be 2 times this. The total, of course, is $121.25. It tells us that, total bill. And then my equation is going to, again, follow that pattern. Now, you don't have to write out the pattern every single time. Hopefully, we've done it enough now for you to know that I'm going to take the rate. So the rate, $15.25, that's how much they're charging me every time I go over. So that's what's going to be multiplied by X. We're going to add on the constant. That's my $75.50. And that should equal the total of $121.25. We're ready to solve. And, of course, this should be old news by now. So we're going to subtract $75.50 from each side. That's gone. We're left with $15.25x. I was supposed to let you all do this one on your own, wasn't I? Oh, well. 121.25, take away 75.50 is 45.75. You can pause the video and see if you get the same answer. And then, of course, we're going to divide by 15.25. And x gives us 3. So 3 times I went over my data limit. So on your practice for this unit, part of your practice is going to be was a worksheet, and I've taken it and making it an assignment in Schoology, where you have to pick out the variable and the constant and the rate. I don't think I put the total on there, and the equation, and then solve it. Some of those you're going to have to do that. Some of them you're only going to have to write the equation and find the answer. So not always, once you get pretty good at picking out these things, of course, you'll just be able to write the equation from being able to recognize these things. But the first couple questions, you have to pick these out, all right? So you're going to practice this, and this is the last part of our unit. And so once you get finished with this, the next thing we're going to do is review everything, and we will finish up Unit 2. Email me if you have questions.